So 12.1 is a review of some basic equations that you should already know, with a couple of new ones that we'll talk about. And then this will be kind of nice because we'll go through a lot of stuff that you've previously done, especially with the ACT coming up Tuesday. It's kind of nice to go through this section. But all right, so there's a list of stuff that you should know. I'm going to just quickly list it. And after I'm done listing it, if there's any questions on, maybe you forgot or whatever, we can talk about it, okay? So you should know the distance formula. You should know the equation for a circle. Jason and Leo, you got notes? Oh, I just dropped one. That's Jason's. Sorry.
Thank you.
Yep. You should know how to find slope. You should know how to work with point slope formula, the point slope equation of a line, and slope-intercept. You should know the difference between parallel and perpendicular lines. And you should know the midpoint formula. And you should know the general process for finding x and y intercepts. Okay, these are all things that we've done at one point or another, and some of these you've even done for a few years now. Any of these that you're like, I don't remember a thing about that? The difference between point slope and slope-intercept. Yes. Typically you use point slope if you have a point and a slope, and the equation for it wasn't meant to be funny, but okay. That's how I remember it. The equation for it is y minus the y coordinate of the point times m times equals m, times x minus the x coordinate. Okay. Slope-intercept is something you would use typically if you have the slope and the y-intercept, so you go straight to mx plus b.
And then parallel lines just have the same slope.
Yep, parallel means same slope.
And then perpendicular have the opposite reciprocal.
That is correct. Oh, I just wrote the same symbol twice. This should be perpendicular, and that is opposite and reciprocal slope, yes. Others? If it's centered at 0, 0, that is correct. X minus the center coordinate plus, yeah. Yeah, and you add them. Yes? Yes? You guys all remember your stuff. That's good. Yeah, I know. You're like, I don't know if I want to say anything, but no, you guys are good. Okay. Then here are some of the newer things. Okay. In this section, we are introduced to something called an angle of inclination. Okay, and all that means is if I have a line, maybe something like this, the angle of inclination is the angle between, the acute angle between the line and the x-axis. Okay? So let's see if this kind of makes sense. If I were to draw a triangle that looked kind of like this, so we go from point to point, what do you think of when you see this image and you're going from here to here? SOHCAHTOA, that's something, and that's, yes, hold that thought. Rise over run, yes. Let's combine the two into one happy thought. Rise over run and SOHCAHTOA. If I have rise over run and I have this angle here, which of the SOHCAHTOAs do you think about when you see theta? Tangent, yeah. Tangent is opposite over adjacent, which is rise over run. And what is the formal name for rise over run? Slope. So here is the angle of inclination formula. If you know the slope of a line, you can find the angle of inclination. Okay? That is correct. You would do inverse tangent, or maybe it's a nice unit circle value like, oh, I know that angle because we've studied the unit circle, so you don't have to do inverse tangent. Here's an example. Okay, now we are talking about the acute angle between the x-axis. So if you have a negative slope, you can do one of two things. Okay, you either take your answer and subtract from 180, because if you do a negative slope, you're going to get an angle larger than 90, or you can just always use a positive slope, regardless of whether it's a negative or positive, because it'll give you the same angle. Okay. Here's an example. Let's say we have 4x minus 4y equals 7, and we want to find the angle of inclination. Okay. What do we do first? Get y alone. And y equals mx plus b. Good. So, move the x term over. And then? So y is going to be x minus 7/4. And now really all I care about here is the slope, right? So the tangent of theta would be equal to what? To 1. And if you remember your unit circle value, you should be able to tell me what angle that is that has a tangent of 1. Pi over 4, otherwise known as 45. Good. It's acute, yeah. So it could be 45 or what would it be? 225, but we're going to go with the acute version. Yes. Not the cute version, the acute version. Okay. Well, I guess 45 would be cuter than a 225, you know. Okay. All right. All right, we've gone from cute angles to anorexia. Hello, YouTube. This is my class from 2016.
Follow me on Twitter, leo.walker.sellout.
Okay. And now that they know they're being recorded, they're going to be even goofier. Okay. Distance from a point to a line. That's the last formula that we're going to learn about. And then I'm just going to do a few examples that kind of merge all this information that we've talked about. So seeing if we can apply some previous knowledge with some of the new stuff. Okay. Everybody got this? Can I remove this page?
Yes. Yeah.
So the distance from a point to a line, that means we literally have a point. So I'll call the coordinates x naught, y naught, and a line. And we are trying to find the distance from this point to this line. And when I say that, I mean shortest distance. So what requirement do I have? It needs to make a 90-degree angle. Very good. So this is the distance that I am looking for. It needs to make a 90-degree angle. Okay. And there's a new formula that will help us do that. We're not going to spend time proving it. I mean, you can. It's just a little tedious. But it's very easy to work with. Okay. And there are two different versions in our text So when you do the homework and it says use this other formula, just ignore that and just work with this one. I think it's easier to remember. So we're always going to work with this one formula. You're going to have to be given a point and a line, and the equation of the line has to be in the form, it's what we call standard form, where everything is set to 0. So ax plus by plus c equals 0. Okay? So if our equation is already in that form, great. If it's not, then that's the first thing we got to do is move it around so that it's in this format. Okay? And as long as we have this point and the line in this format, then the distance from this point to this line is the absolute value of a times the x-coordinate plus, nope.
Yes.
Now you say determinant. Okay. Plus b times the y-coordinate plus c. It actually looks exactly like the equation of the line, right? The only difference is you're plugging in the x and y coordinate of the point, okay? And then you're going to divide by the square root of a squared plus b squared. Okay, so this nifty little formula will help us find this distance pretty quickly. Okay? So here is an example. I'll give you a little bit of time to think about it, and then we'll go through it together.
Yeah.
Again, this is not horrible, just so find the distance from, let's say, 6, 4 to the line y equals negative 3/5 x plus 6/5. You know, I wonder if I turn on the lights if it makes the video version look better than what I'm seeing. Oh my god. Sorry. Does that help this? Actually, it does a little bit. Okay. Sorry. I know we're all vampires in here, but... All right. So what do we have to do first? Yes and yes. Let's combine the two thoughts. I would multiply by 5 first, so I don't have to deal with the fractions, right? So 5y equals negative 3x plus 6, and then we set it equal to 0. I don't really have a preference. Which way do you want to go?
Right.
So 3x plus 5y minus 6 equals 0. It's not going to matter. It's just a matter of preference. All right. So we are set up. We are good to go. Here's our point. Here's the line in the proper format. So then the distance is just going to be the absolute value of what? What's A?
A is 3.
So 3 times
6
the x-coordinate. Good.
plus 5, 4.
Yes, 5 times 4.
Plus or minus 6.
Minus the c, or plus the c, which is negative 6. So subtract 6. And then the square root of 3 squared is 9. 5 squared is 25. So we divide by the root of 34. So then in the numerator we have, what is that?
Lots of numbers.
8 lots of numbers.
18 plus 20 is 38, 36.
So it's just 32
Yes.
over root of 34. And then ACT does like reduced and rationalized answers. Oh no's, yeah. So that's 32 root, you mean 34. But then we can reduce,
Yes.
so that's 16 over 17. Oh, shoot, I wrote a 7. Man. So 16 root 34 over 17. My brain was ahead of my hand, so I was already on the 17, and I was still technically writing 34. Okay. Yes?
Does it matter if we get rid of fractions?
No.
Nice.
But it's a messer. It's a messer. It's more messy to simplify it at the end if you got all the fractions in there. So I would advise to get rid of fractions at the beginning if you can. All right, you guys good? Okay. Now let's go a little further. Oh, well, I'll just use. Yeah. All right. So here's another example. Let's say we want to find the equation of a circle centered at 7, -3, tangent to the line y equals 3x minus 11. Okay. Any ideas?
Yes. Oh, never mind. I don't like it when it says tangent.
The word tangent scares you?
Yes. Because in physics, it always screwed me up. So now I'm
Well, it's very important here. In fact, if that word weren't there, we would not really have a problem to solve.
that's true. Like when we were
What do we know so far? Why don't we start with that? We know the center of the circle, and we're looking for the equation of the circle. Why don't I just start filling it in? What do I know then?
Wait, x minus 7 plus y or squared.
Yes, squared. Don't forget the squared. Plus
Nice.
1 plus 3.
Yes.
equals
D squared.
the radius squared. Yeah. Okay, so this sheds some light. All we really need to do is just find the radius somehow, right? I have everything else. I just need the radius.
So we do that from the other thing.
What do you mean, do that from the other thing?
Like this, the tangent is
Because
this
this
point.
is
So
formula.
that's what it is. So you know,
Tangent of theta.
I'm hearing like everything all at once.
absolute value of A is equal to 3y plus C.
Use the distance from
Yes.
that new formula. Can we? Let's draw a picture first so everybody knows what's up. Okay. Center's over here at 7, -3 somewhere. Okay. Let me put this down so we can see it better. And now we have this line. -11 is down here somewhere. Slope's +3. So let's just pretend that this is the line, right?
That's gorgeous.
Thank you.
I can't draw straight.
I did, take line drawing 101 in college, so my hard-earned money did pay off.
Along with circle drawing.
Along with circle drawing, yes. That was the next course.
You know the dotted line? Yeah, the dotted line.
Okay.
Just for the video, like sound.
What?
Like doing the dotted line.
I can't do it here. Oh, maybe later. Okay. So if it's tangent to the line... Oh, see, now I just embarrassed myself with this horrible circle.
Go back to circle.
I can do them on the board. Okay. And here comes one of my favorite students, late, without a pass, with what seems like a mini boombox, walking through the halls. Okay, so if we look at the scenario here, this length here, that is the radius. What do we know about this angle from radius and tangent line? 90 degrees. So not only is this the radius, but yes, this is that new distance from a point to a line equation. All right? So to find the radius, we're going to do absolute value of some stuff divided by the square root of some stuff. Before I plug into that formula, though, what should I do? Yes.
Yes.
Put this in standard form. So let's just write that over here. Just for the heck of it, I'll put it all on the right this time.
Yes.
So 3x on the right, and then minus y minus 11, right?
Yes.
And so there's our standard form line. And here's our point. We are set up and ready to go.
Nice.
So what should I put in the absolute value here?
3.
Times?
7.
Yes.
Yes. 1.
Plus
1.
plus negative 1, because that's the b, times
3. Isn't it
negative 3, plus the c value, which is negative 11. A squared and b squared will be 9
Yes.
and 1. So then 21, 3, subtract 11.
That's 24 minus 11,
So we get, whoop, put the root in the wrong spot. 13 over root 10. Oh, speaking of rationalizing, you could say 13 root 10 over 10, but then where are we going to plug this in anyway? Back in here for the radius squared. So, yeah, just leave it, because the square root will go away.
Nice.
So my advice, do not rationalize until you know you need to. So I would just plug this in, square it,
Nice.
you get 169 over 10. So this would be the final answer here. Okay? Is that good? Make sense? Does tangent still scare us?
Yes.
Yes.
You're supposed to say no.
Tell the story.
Okay. Next example.
Yeah, we want to hear that story.
Next and last example
Last like for this entire year.
for today. Find the area
I'm being abused, Mr.
of a triangle. What's that?
I'm being abused.
Just for the record, she is kidding. I'm.
No, by Rachel, not by Mr. G.
Find the area of a triangle with vertices
Yeah, he's not going to put it in.
at 4, 0, 1, 1, and 2, negative 5. You guys are so giggly. I don't know.
You can be called.
Teacher fired
Oh man,
He's like giving up on that.
I might just stop this video.
No.
Okay. How about we take 30 seconds, read the question, maybe draw a picture. What?
Yes,
I didn't hear what you said.
Milk.
we need some milk.
We need milk.
Yes.
Are you? Do you have a lactose in it? You know? Don't they sell milk down in the cafeteria?
Yeah, they do.
They do.
You didn't get any today?
No, I have time.
Oh. We have some in the math office. If you want, go grab a cup.
Not right now.
Okay.
Oh, you gotta do the distance formula.
Wow. There's abuse. There's students realizing what needs to be done and getting so sad. Oh, man. Okay. I'm just going to draw the picture.
Mr. G, why'd you decide to take a video of
Because it's not up yet. We don't have a lesson for this on.
Yes.
To make things a little easier, I'm going to call these A, B, C. So this is where A is. B will be here. C is at 2, and then -5, so somewhere right around there. And this is the triangle that we need to find the area for. And I mean, just to make sure you guys see, we do not have any right angles. We cannot assume that even if they look like they are right angles. Okay? All right. How do I find the area of a triangle? Sure, so let's write that down. Well, I know 1 out of 3 things. I have the 1/2.
Well, does that really count?
That was the joke. I need a base and a height. Well, we should probably pick one of these to be the base, right?
BC. You can't just have C.
As long as it has C.
BC.
As long as it has C in it, so you don't want a...
No.
BC.
Not C.
Okay, all right.
Thank you.
So we're going to call this the base. So then our height would have to be from A down here somewhere, and it needs to make a right angle, right? So this would be your height. So can we find the length of this base?
Yes.
Okay, let's do that. So
Yes.
we need to use the distance formula. Not the new one, but the old one, right?
Oh.
So that'll be the square root of... I'm going from B to C. So it's the difference in x, which is 1 squared, plus the difference in y, which is going to be 6 squared. So the distance is root 37. All right, so now we have half times root 37 times something for the height. How could I find this distance from this point to this line type thing? We have to find a line equation. Very good. Because we know this point, and technically, even though we don't have a line, this segment, if I found the distance from this point to this line, it would be the same distance as the point to the segment, right? So let's find the equation of the line. So how do I find the equation of BC? Slope, very good.
Nice.
The slope from B to C. So looking at the coordinates, change in y over change in x, right? So 1 minus -5. Almost. Well, depending on which order you subtract in, it could be one or the other. I did 1 minus -5, so that'll be 6. And then 1 minus 2, -1. Oh, you had your answer. Okay. Okay. So we have the slope. What else can I do now? Point slope, very good. So, y minus the y, do you want to use B or do you want to use C here?
C.
I like B because they're both ones and there's smaller numbers.
Fine. All right.
So y minus 1 is going to equal negative 6 times x minus 1. That's putting it into point slope form. And if we're going to find the distance from point to line, what do we do next here? Yes. And then,
Left one.
which side do we want to go to?
Left one.
Left side?
Yes, get y alone. Wait, what? Y alone. Or do you need to make the ax?
We got to get it in in the standard form. So what side? Okay. So 6x plus y,
Yes.
this would be minus 7, right? And now we are set up. So we're going from point A, which was 4, 0, right? So 4, 0 is our point, and here is our line equation.
Yes.
So rather than D, I will use H, since that's what we're really finding, right? And that'll be the absolute value of 6 times the x-coordinate. Well, that's why I circled the point. 4 plus 1 times the y-coordinate, 0, plus the c value, which is negative 7, over the square root of 36 plus 1. So root 37 is the denominator. What's the numerator? 17, yes. Okay, so we're pretty much done. We had 1/2. Base was root 37. Well, that's nice. Again, don't rationalize unless you need to at the end. Okay? If you leave it like this, can you guys see right away that these cancel? So the final answer is 17 over 2 for the area, whatever units we have squared. Okay? What's that? Too long? Oh, this is nothing. Just wait until next unit.
Oh, great.